Okay, we reached the third and final of our motions that we're gathering data for. This is part C, CPM. And we're going to go ahead and run the motion, see what it looks like. Okay, and we're coming to a stop there, and we'll reset. So go ahead and write down what kind of motion you think it is. Again, constant position would be rest. Constant positive or negative velocity would be moving with equal amounts of distance per unit time in the same direction. Positive would mean the positive direction, negative would mean the negative direction. And then constant acceleration, which would indicate we are speeding up or slowing down as we move either to the right or the left. Go ahead and answer those first two questions under number 1, and then we're going to go ahead and collect data. Again, we're going to collect displacement data off of the green and the velocity data off the red for each half a second here. Okay, so at our initial point, 0 time, we're at 0 meters and 8 meters per second, so we're already in motion. Then we get to half a second, we're at 3.75 meters and 7 meters per second. And then the next one, at 1 second, we're at 7 meters and 6 meters per second. And then we're at 1.5 seconds, so we're at 9.75 meters and 5 meters per second. And then at 2 seconds, we're at 12 meters and 4.0 meters per second. And then at 2.5, we're at 13.75 meters and 3 meters per second. And then at 3 seconds, we're at 15 meters and 2 meters per second. And then at 3.5 seconds, we're at 15.75 meters and 1 meter per second. And then at 4 seconds, we're at 16 meters and 0.017. That's, we're going to round that off essentially to 0. So we pretty much lost all of our velocity, and we're now at rest. So fill in the table again. If you need to pause the video, go back and fill in whatever pieces you missed. You'll then be calculating the acceleration for this particular motion. Again, it will be constant. If you get a number, whatever that number is, whether it's 0 or some value, positive or negative, it's going to be the same throughout the entire motion from beginning to end. In terms of the graphs, the displacement graph, we get a curve. Notice that the curve is becoming shallower, indicating we're slowing down. Now for the velocity, the red graph, we're talking about as we move to the right, so when we're in positive direction, that means we'll be above 0, we are slowing down. And in fact, we end at 0, so our last point should be on the 0 line of the graph. So in fact, that's what we get. We trend downward from our initial velocity until we hit 0. Again, that's showing that the value of the acceleration is constant, and it will be equal to the slope of that particular graph. Okay, so you've seen all the videos. At this point, you should be able to describe each of the motions thoroughly and completely using the appropriate terminology. Okay, again, the word constant is not good. By itself, it's no good. There are too many different things that may be constant. Your position might be constant, or your velocity might be constant, or your acceleration might be constant. And if one of those is constant, the others can't be. So you need to combine constant with either velocity or acceleration or position. And you should be thinking also in terms of direction. Is it a positive motion? Does that mean the velocity is positive? What about the acceleration? If it's speeding up, the direction of the motion and the acceleration should match. So if we're moving to the right and we're getting faster, that indicates we should have positive constant acceleration. Look for similarities. Again, ways that you can find that they are similar or go together are important for helping your mind set things straight. And then look for some differences of how they are different. Again, you can go back and look at the different videos and compare and contrast if you need to from here. Okay, so that's it for this. This should get you a sense of the different types of motions that are available and how they will look. Ways we'll be able to analyze them using both position and velocity time graphs, and later some equations.